Hello, everyone, and welcome to today's webinar, What DevOps and SREs Need to Know About Mobile Observability. My name is Colin Contrary. I am the head of content here at Embrace, and I will be your MC for today's webinar. For the best audio experience, please use your computer's audio as opposed to dialing in. And now, before we get started with the webinar, we'd like to cover a few housekeeping items. So the first thing is this webinar is being recorded and it will be made available to you after it's processed later today, so you can rewatch it and share with your team. The second is we will have a section at the end for questions. So please use the GoToWebinar chat box to ask any questions, and we will get to as many of them as we have time for at the end of the webinar. And with all that said, I'd like to hand it over to today's speaker, Frederick. Hello, Frederick.
Hey, Colin. Thanks for that intro. Hi, everybody. I'm Frederick Newberg. I'm the CTO at Embrace. I've been working in the mobile ecosystem for 15 years, and also have a fair amount of experience working on backend systems and monitoring them. So looking forward to sharing some learnings about mobile observability and how it's different than a lot of things that you have to do for backend observability. Just a few quick words about Embrace for those of you who are not familiar with us. We are the only user-focused mobile observability provider in the market with an open telemetry solution. We have open source SDKs that you are free to embed in your apps, and you can gather observability data with those, and they will be delivered using open telemetry standards, and you can choose to send them to your own observability backends, or you can send them to our backend where we do a lot of analysis and work around a lot of the observability issues that we're going to be discussing that exist in mobile today. So without further ado, let's dive into things. So why are we all here? We are here to talk about how the fundamentals in mobile are different and how they impact observability. So I'm going to step on a limb here and assume that most of you know a fair bit about backend observability. So I'm going to contrast how that is different than mobile observability. So often in backend, you're monitoring things like services where you have small, well-defined amounts of work that you're looking to complete in milliseconds. If you have endpoints that take seconds or even tens of seconds, that would be not the best performance experience that you're looking for on backend. Whereas like in mobile, you monitor highly variable behavior over the course of tens of seconds or minutes or even hours. And with backend, you typically have server types that are pretty consistent, controlled. You can upgrade them. A lot of you are probably on cloud solutions where a click of a button or deploying some scripts or running some runbooks will make those changes happen, and you can go from one set of server types to another, and it'll be easy and it'll be well defined. In mobile, that's not the case. You may have an app that you're responsible for that has over 4,000 different device models with at least 10 users each that we're seeing in a day. In a lot of Android apps, we see that the most dominant device may account for like a couple of percent only of the total user base. In backend, the networking is controlled by you and is hopefully most of the time stable and predictable, whereas in mobile, it's certainly not. You control very little of the network other than where you do your data ingestion, but data is coming from all corners of the internet, and sometimes people will have highly variable experiences even during the course of a session. They may walk down into the basement or get in an elevator, and what was a great connection turns into a terrible one or no connection at all. In backend, you typically deploy versions rather deterministically. Maybe you have canary builds that you put out there that run a small percentage of the workload, and when that all looks good, you upgrade, but rarely do you run a large variety of app versions. That's not the case in mobile. You have really no control in many cases of when customers upgrade. Some install once and keep that. So being used to supporting multiple app versions needs to become the new norm. So hopefully that has sort of set the context on how really everything is in many ways like the opposite in mobile land than it is in backend land. And we're going to dive a little bit deeper into mobile to kind of give you some more concrete examples of how things are different. So we're going to start out by talking about how to think about mobile interactions and really thinking in terms of sessions. So we look at a session as an abstraction for capturing a segment of app behavior. You kind of need to come up with some abstraction for that. And the goal here of the session abstraction is to basically two things. One is to align with how users think about their app interactions, because ultimately when you're trying to debug things, that really helps you understand what did the user experience, what were their intents, and then also how the operating system treats app behavior. And there are really two primary modes of operations for mobile apps, and we'll get into a little more detail on that in a few slides. But there's foreground mode, where the app is being displayed on the screen and maybe being interacted with, but also background mode, which can be doing some very important tasks to make the overall end user experience what they expect it to be. And really one of the key things too to think about with mobile is that sessions maintain state. If you're used to monitoring backend services, you're probably used to a much more stateless experience between requests, whereas in mobile, state is maintained over a very long period of time, sometimes longer than you wish it was, because it'll cause complications for you. And we'll get into a little bit more what that means when we talk about the foreground and background modes. So the other thing, just to kind of like give a sense of how long sessions can be, like if you compare this to what I mentioned earlier, where you want network requests to take on the order of milliseconds, session durations in mobile are much, much longer. If you look at the vertical scale, it's in seconds, not milliseconds. And these are a couple of different media apps, but you can see pretty different behavior from the end users, where the P50 of app number one is still quite low and significantly less than a minute, whereas like the P50 for app two is probably around a minute. And when you look at like the P95 times, they've diverged quite a bit, where the P95 is at probably about 3.5 minutes for the blue one, and much, much longer at 10,000 seconds, or I'm sorry, 1,000 seconds for app number two. So even there, it's like, this is to kind of illustrate that there is not a one size fits all. Usage patterns are going to be different. You're going to find some apps have extremely long times, like maybe you have a podcasting app and people actually put it in the foreground and it'll sit there literally for hours. And maybe there are other things like a weather app where people like breeze in, see like, yeah, great, it's going to be sunny, and then they leave 10 seconds later. One of the things too, building on the statefulness that I mentioned earlier to think about, is what we've called session stitching. Users often use apps in bursts where they're looking to carry out, they have some goal. Maybe like, let's say they're using a food ordering app like DoorDash. They come in, they start looking around for food, they get a phone call, they get interrupted, they take the phone call, they get back in there, they pick a restaurant, they order the food, they go do something else, they look to see where the delivery is, and then when the delivery arrives, they go maybe like rate it, give a tip, something like that. So if you think about a session as being when the app is in the foreground or is in the background, you'll see there are a lot of transitions between those. And given how application state is managed, oftentimes the process for the app will be launched, and it will sometimes like stay active in the background. Sometimes it'll be terminated by the OS because there are other apps competing for resources. You really don't have a whole lot of control over that. But the idea of kind of keeping this journey of interaction together is important, because you're trying to understand, like, oh, maybe there was like data that was delivered here through an endpoint that's going to be used in the next session. So it's really important to understand the whole path that the user took in terms of debugging issues a lot of the time. So as I mentioned, there are two primary modes of operation. There's the foreground mode, which is pretty straightforward. The app is, as the name would imply, in the foreground, and maybe you're just viewing it, maybe you're actually interacting with it. It doesn't really matter if it's displayed, it's in the foreground. But the background is also a really important component of how an app operates. And it'll vary a little bit depending on the type of app, how much is done in the background, but a surprisingly large number of apps have critical things that do happen in the background. And this can be getting push notifications and responding to those. It may be that you have a scheduled download of data that occurs. If you are on Wi-Fi and at 3 a.m. every morning, it downloads some data to make sure it's ready for the next day. It may be a case of shortly after you backgrounded the app is working to complete stuff that was started in the foreground. Maybe you're uploading a video, and those things are really challenging to understand because they happen outside the scope of when the user was interacting with it. But ultimately, when the user comes back to use the app, if you haven't handled the background behavior correctly, then you may leave the user with an experience that is not what they expected. So understanding what is happening in the background can be really critical for many applications. That's unlike a backend service where there normally is really only just one mode of operation. All right, so next, let's turn to understanding the mobile operating environment, which has a lot of differences than what you might be used to from running a backend service. So the first thing that I kind of alluded to earlier is that there are lots of different devices. So here's a fairly pedestrian app in our system. It's 5 million sessions, 1 million users in a day. And if this is an Android app, it would be quite common for it to have like 4,000 different device models. These may range from quite old Android 6, Android 7 devices, all the way up to more modern Android 14 devices from a slew of manufacturers. On iOS, it will look a little bit different. You probably might still have about 70, 80, 90 different models in iOS, but obviously with just one manufacturer, it's not going to be quite as broad. But there's still an opportunity for lots of things to be different, lots of things to go wrong, even with that number of devices. But just thinking about the fact that you have all these different devices is pretty important. And that kind of leads me into like the things that you normally are used to controlling for a backend app really don't exist. You have no say in how much CPU and RAM you have to support the app. It's whatever the device had. And things have certainly gotten better with a lot of newer devices having 4 gigs, 6 gigs of RAM and reasonable CPUs. But there's still a lot of devices out there that are either older or sold into certain markets where they're looking for more economical device options. So some of our customers we found really have some challenges dealing with the lower tier devices, and you kind of have to think through that because oftentimes in QA you aren't really focusing on that. How much disk space you have available is not under your control. If you're running out of disk space on your backend servers, you provision more disk space or you get more servers. Or you use something like a cloud storage where there isn't really a strict bound. That's not the case with mobile, where you are stuck with whatever device the person chose and how much space they have left on it. Surprisingly, many devices are pretty low on disk space. I was surprised when we first started to see just how many devices are running within a gig or two of being full. Excuse me. The network bandwidth is not under your control. you really don't have any say in what kind of network the device is on. And you really can't say that even over the course of a session that things will stay consistent. The app will often restart between sessions. You really don't have any say in how that happens. And the OS will determine whether it happens or not. This is unlike where when you're running backend services, you kind of get to choose when you restart your apps most of the time. The performance across different devices will vary quite a bit. We did some tests on iOS, and we benchmarked what the difference was based upon the release year of the device. And it's quite interesting if you look at this. We benchmarked here to just like 2023 devices being benchmarked to one. And you'll notice that even if you just go out to 2019, excuse me, that you will have a 2x difference in the performance that you will see out of your device. So that means that if you're doing performance monitoring, you kind of need to adjust for that, and the baseline you pick should probably be related to a device or a device year category. Otherwise, you may either fool yourself into thinking that you have a problem when there really isn't one, or you may think that you're seeing improvements when really all you're seeing is people getting newer devices over time when really you didn't make any improvements to your own code. One thing that may be a little bit surprising is not getting data delivered in a timely fashion. The norm in backend is that people have an agent that is running on your server or in your container, and it's going to deliver stuff pretty much immediately to your observability solution. That's not really true, at least not consistently true with mobile. As you can see here, like we're looking at 4 different apps where we're looking at how long is the delay between when an event occurred and when it's delivered. And you can see in app number 1, almost everything gets delivered within a minute of it happening. So that's great. And the second app, that's not bad either. But by the time that you get to third and fourth app, you can see that there's actually like a lot of data being delivered even a day out or more than a day out. And this happens due to network connectivity things. Maybe people started a session offline. Maybe they started online and completed it offline. Maybe their internet connection turned poor and things couldn't be delivered. And it's really important to think about how this affects your overall observability system. Metrics will change as more data is delivered and processed. Can your system handle that? That's something that we spend quite a bit of time working on at Embrace to get right. And if you're looking to export data to different systems that don't support updates, you have to kind of make a decision like, well, when is enough data present that you can export and get a good picture versus like, did I wait too long? And then, I wanted to be aware of something that was happening, but I was hesitating to export because I didn't feel like I'd had enough data. And the right answer for dealing with this often is app or org specific. So there's really no right answer to this. It's something where I would say your mileage may vary and you need to kind of assess where you stand with what the delay profile is for your app. Also, I mentioned earlier that app version adoption is nothing guaranteed. And here we can see certain apps which have different adoption profiles. And again, the first 2, they're doing pretty well. they have probably about like 85, 90% people on the latest version. But then as you move further down, you see that there are versions or applications that have 4, 5, 6 versions that have dominant, or not dominant, but significant usage on them. And you kind of need to think about how you want to deal with that. It's obviously some users aren't getting the latest and greatest features. So you may have things where there was a bug fix put out in a recent version that's not being adopted. And also, a different perspective to take is like, when can you deprecate things on the back end? How do you manage your app versions? If you have, if you look at app number 5, right? If you deleted or wanted to delete an endpoint that was not used in the last 5 versions, it's like, well, you still have about 10, 15% of your traffic on version that's 6 versions old and older. So are you willing to remove that endpoint from the backend service and have the experience break for those customers? Or are you willing to keep it around longer, even though it may be like, leading to tech debt? So those are some of the challenges that you'll be faced with, given that you don't really have full control in most cases of app version adoption. All right, let's move on to like understanding some of the ecosystem constraints. So one of the first things to be aware of is that you don't have root access on these devices. Privacy has become an ever bigger thing on iOS over the years, and Android really isn't far behind. You're not going to be running an agent on the device, and you have to acquire all the data you get from the context of the app. Both Android and iOS provide some APIs that kind of help you work around this to some extent, but it's fairly minimal. And the real takeaway, I think, is like, you have no visibility into what is going on around you. You might be able to get some pretty decent stats for your app, but you don't know if some other app is doing a download in the background that's impacting network bandwidth, or if some other app is using some amount of CPU, or maybe there are multiple apps that are using CPU and is kind of hurting you a little bit. You just don't know whether that's happening, and that's sort of by design. I mean, as I mentioned, privacy is a huge thing in mobile, and you don't want to give that visibility, which could be used for nefarious reasons, and that is definitely a challenge in observability. There are also a lot of performance rules that you need to think about. When you're running backend services, it's kind of like up to you to set what the rules are. Maybe you want to stop certain runaway processes or runaway requests, but here you have to kind of live with what the ecosystem enforces. And iOS will kill your app for a large number of performance reasons. If you use too much CPU, for example, you have 30 seconds after going to the background to take care of everything you want to take care of before iOS will just terminate your process. If you have long hangs, if you use excessive I/O where you're writing a lot to persistent memory, there are limits on that. And some of these things might be really hard even to see in QA or during development. But if you have a million devices producing millions of sessions a day, you will see these types of errors occurring. Android's a little less aggressive, but Google has other ways of punishing you in terms of discoverability for poor performing apps. If you have a crash rate that exceeds their prescribed norm, it'll be harder to find your app when searching in the App Store. Same for ANR, application not responsive rate, startup time. So Google is a little more transparent in these things. Admittedly, they don't provide a whole lot of data to help you solve the problems, especially the ANRs is like a big thing where we've done a lot of work around to make those more solvable than what Google's data really allows you or gives you when you try to tackle them. So there's a bit more transparency, but there's definitely room for improvement there from the ecosystem maintainers, in my opinion. And background behavior is strictly regulated, much more so on iOS and Android. There's a whole lot of rules. There's a whole lot of modes you can operate in iOS. There are things where you can go get exemptions from Apple because you have a certain type of app. And if you deal with Bluetooth or things like that, you may get exemptions, or if you have a music player. Android's a little less strict, but you want to avoid running afoul of them because iOS will punish you when you exceed the rules, and then it will give your app less opportunity to do stuff in the background. Crash reporting is also like something I think is worth calling out, because obviously it's, looking into crashes, being aware of crashes is of a primary concern for app developers and owners of apps. Probably the most commonly used metric in the mobile ecosystem is crash-free percentage. So this is something that we really focus on. Some things to be aware of: both iOS crashes and Android native crashes, they are going to be reported on next launch. You really don't have a whole lot of say in that, just how the ecosystem works. Both of them require symbolication, which means that you need to take some of the artifacts created at build time combined with the data coming off the device at runtime, and combine that to produce human readable stack traces. And that can be a little bit challenging. And we've certainly found a lot of corner cases over the years that we've had to build and support for. Android JVM crashes are typically reported immediately. Most of them will require deobfuscation. It's pretty much industry standard, I would say, to obfuscate and minify apps using tools that come in the Android toolchain. So what you have coming off the device is probably also not going to be human readable. And one other thing that's noteworthy about Android native crashes is that most Android Unity crashes are of this type. So even if you have an Android app and you're thinking, oh, it's going to be mostly JVM crashes, for certain things where you have frameworks that are used to build the apps, they may lead you to having native crashes, which typically are a little bit harder to tackle than the JVM crashes. All right, so the last thing we're going to dive into detail is client-side networking. I think this is an interesting thing to think about, because you're used to thinking like, oh, well, I have a lot of visibility into my networking and how that's going because I'm monitoring on the back end. And while there's certainly an element of truth to that, I feel like it doesn't tell the full story. Starting off with the fact that not all requests make it to the back end for a variety of reasons. The first one's probably pretty obvious, right? Like, hey, you have no internet connection. And it may seem kind of silly to include that, but I do include it because I continue to be surprised by how few apps gracefully handle the lack of an internet connection or the loss of an internet connection. It's getting better, but the percentage of apps is surprisingly small, in my opinion, that handle that gracefully. You have DNS failures. If you can't resolve the host name to an IP address, your backend isn't going to see the request. And while you may get some data when a connection is interrupted or the SSL handshake fails, things like that, my experience is like that data is not necessarily easy to correlate to individual users. So if you're trying to tie it together with other data, it can be kind of hard to see what's going on. Obviously, if the SSL handshake fails, you're not going to have a whole lot of information about that request. And then there's the case where maybe your server load is high, like you're getting hit with a usage spike that the system wasn't quite ready to handle, and that may mean that you're not really logging everything. Stuff just kind of falling to the floor in some cases. So there are a lot of things where if you're not looking at it from the client side, you're really not going to get a complete picture. And perhaps equally importantly, many requests are not for your backend, and many of these services, these service types, are critical to the successful operation of your app. You have like payment providers, ad providers, map services, CDMs. There's like a long list of things. And I feel like this is a little bit overlooked. If we look at the data in terms of connectivity, successful connections where things are maybe just like getting like 400 and 500 responses, I see an outsized number of these third-party services with higher rates compared to the backends that are built by the company who are operating the app. So I think in some cases people are just oblivious to they set it up. Maybe something changed with an authentication key. In some cases, we've even had customers who are surprised that certain domains are still being hit because they thought they removed that SDK or turned off the service. So this is something where you're pretty much flying blind if you don't do client-side monitoring of networking for mobile apps. Also, if you just think about how a request is made from a mobile app, there can be many components of that request where you don't have visibility into performance. Like, first of all, when you make a request in an app, it gets queued. And if you look at the commonly used libraries on both iOS and Android, you will find that there are limits on how many concurrent requests are allowed to be made to a given domain. And we'll see on the next slide why that's really important. So when you make the request from the perspective of the app, you're like, hey, I'm sitting around waiting, but it may not even hit the network layer for a substantial amount of time. You have DNS lookup, surprisingly poor in certain parts of the world, as we've discovered working with some of our customers. The whole TCP TLS connection establishment, maybe you have visibility into it, but it's probably not as good as you wish it was if you're doing it from the server side. And the request sent, obviously you can understand that in the backend processing of the request, yeah, sure. But even the response being sent is not always clear. I did an experiment. I thought I understood this stuff pretty well, but I wanted to make sure that I got it right. And I did an experiment with Nginx where I wanted to understand what it reported as the request time for a given request. And what I found was that if it was a small request that fit into the memory buffers in the kernel, Nginx was just going to kick the request out and say like, oh yeah, I knocked this out in like 10 milliseconds. And then it was on the kernel to actually deliver it. So Nginx was kind of undercounting that. So even there, you may be kind of missing out a little bit on what's going on if you're relying on that. And then obviously the response parsing by the device, you have no visibility into. If you send a very large JSON payload, by the time something's actually done with that and information is presented to a user, that may be a very significant component of the overall time spent by a request to go from the point where you initiate it to where it has delivered value to a customer. As I mentioned earlier, request concurrency can be a problem. One of the things that we've seen is that as teams have gone larger, and this has been kind of a shift in the industry, I would say, over the last 6-8 years, where we used to see a lot of mobile teams where there's like maybe 3-4 developers on iOS, maybe like 3 developers on Android. Now we're seeing a lot of teams that are like 25, 50, maybe even 100 devs. And an outcome of that has been that the structure of the apps have changed, the way that you had to break it down in modules has changed. And that's often meant that people really aren't communicating as well as they were. So you get this where you get a lot of redundant requests that can happen. And here in this case, you see that there are a whole bunch of requests made to the same endpoint. Excuse me. And you really didn't need to make all those back-to-back requests, but you had people from different teams who weren't talking to each other and they all needed the same data. And here's where you ended up with that, like just kind of like dogpiling on on your server. But also importantly, like it hit the queue on the device and maybe you exceeded the maximum number. Let's say it was 6 concurrent requests. So maybe you had 10 requests going out and you would have to wait for like one of the first 6 to get completed before 7 went out and 8 went out, which really slows down the overall operation of the device. If you're looking at the back end, you're like, hey, I'm knocking out these responses in respectable amounts of time, but that's really not what the end user is seeing. All right, so in summary, we talked about how the fundamentals in mobile are different. There are a lot of things that are the polar opposite in mobile observability from what they're in backend observability. We also talked about how you need to think differently about mobile interactions. There's a lot of different things happening in a session. You may be dealing with just somebody who logs in and does a product search and then leaves, or you may have somebody who goes through the entire product purchase flow, and a session encompasses a lot of different things. That's very unlike back-end services where very discrete things are done in, say, a single endpoint. Also, we talked about how the mobile operating environment is very different than back-end environments where you don't have a lot of control over things, so there are rules that are imposed on you that you have no say in and that you need to work around. And finally, we talked about the client-side network monitoring as an example of where you may have some observability with your backend monitoring, but you don't have quite as complete a picture as you really would want to be able to give your mobile developers the best chance to troubleshoot issues that are reported. So thank you very much. I really appreciate you all joining for this webinar and logging on today to talk a little bit about this topic of mobile observability. Thank you.